stage. Give it up for Joseph, you guys.
All right, thank you. I'm representing TechX Mining and Gaming PCs, and we're located in booth 79, and we're in partnership with ASIC Exchange. I'm going to provide a 10-minute primer, which is really should be an hour presentation. So I'm going to go fast, and it's 10 minutes. If you use these tips when you pick a miner repair supplier, you will be successful. And if you are a current miner repairer, you use these tips, you'll improve your business operations. TechX is a high-density electronics manufacturing repair facility. I have a lifetime of manufacturing experience. I've been 30 years been an executive in electronics manufacturing companies. I've built over 5,000 assemblies. That's unique products, 5,000, and sourced over 1 billion electronic components times multiples. I know electronics manufacturing. TechX, we have a 10-acre campus. We're located in West Virginia, strategically near Ohio. We're really a Midwestern company. We have 85,000 square feet of manufacturing space. We have S&T and through-hole placement machines. We run about 50,000 components an hour as our through-hole is our capacity. And we are experts in lean manufacturing and Industry 4.0 principles. Our strategic vision for 2022 that we set off probably almost a year ago was we wanted to be the highest volume cryptocurrency miner repair facility in the USA by 2022. We currently have developed 12 proprietary manufacturing processes, 30 patentable custom tools, and we have a proprietary data analytics software that gives us component level and task level analytics that we share with our customers. Our goal is by the time we implement this process, 99% of all miners that are sent to us will be able to repair. So on to step one. Step one, you have to ensure the facility you're picking is a qualified facility. You never select your supplier based on their ability to be understanding cryptocurrency mining. Once your miner fails, if I own the miner, in my mind, it's not a miner, it's a high density, broken, substandard performing electronic assembly. And you have to treat it as such. You have to pick suppliers that know how to fix those. So you gotta ensure, step one, that they know the basics. They gotta have adequate facility, equipment, and infrastructure. They have to have a quality management system. They have to have standard operating procedures. And they have to have certifications or proof of compliance to those procedures. TechX, we have the facility, we have the equipment, we have the level 1 quality manual, we have 15 level 2 SOPs that govern how we do our operations. We have thousands of level 3 documentation, which is work instructions. And we've been certified every quality standard, every workmanship and quality standard, any standard you can imagine, we've been certified and being compliant to. Step number 2, experienced personnel. So in the first slide I said you got to think of it as electronic assembly. Second slide, you don't base your selection upon the debug tech. The most important guy fixing your miner is the repair technician. Generally speaking, these miners are really easy to diagnose. They're really, really difficult to repair correctly within workmanship and quality standards. Any person who attempts to solder, even put heat onto the hash board, should have 5 years minimum production experience. That means not a hobbyist, that means 5 years sitting on a production line, 8 hours a day, putting out product. It even gets more complicated. The workmanship, the industry standard, classifies electronics into 3 different standards. Class 1, consumer electronics. When they break, you throw them away. Class 2, industrial electronics. More quality, driven, longer lasting. Class 3, high reliability electronics. If you look at the industry definition of Class 3, a minor is a Class 3 electronics. So not only do they have to have production experience, they have to earn the Class 3 certification to work on your minors. 3 things will help you understand that. IPC 610, acceptability of electronic assemblies. IPC 7711 and 21, standards for rework and repair. And J Standard 001. Here's what they look like. When you interview your potential repair facility, they better understand what IPC 610 is, and they should look at that every single day. That document should be used. The other 2 are confidence builders. As an example, this is a training facility that we provided for Antminer, and it's a maintenance training facility. We can train 30 people at a time in that room in our facility. But the real important thing on this slide is the crowd around the person. The person in the middle of that crowd is a TechX employee who went through the training, not an instructor, and they came in groups of 6 to stand around her to see how she repaired these boards. Those are the guys you want touching your minors, and she's a Class 3 certified trainer. The third thing, prevention of thermal shock. Ask your supplier, how do you protect these ASICs when you take them on and off? They should be able to tell you, we preheat them, we soak them, we reflow them, and then we let them cool down. Because it's real important, not only the rate you put the temperature to it, but the amount of temperature. It should look like that graph. Real quick, the graphic on the side shows a cutaway representation of an ASIC. There's a wee little wire that attaches to a lead. You put too much heat to it, that wire will crack, fracture, or break. Number 4, ESD written control procedure. No circuit card should ever be touched by your supplier without a wrist strap grounded into the ground of the building. They should have a facility-wide ESD control plan that ensures it's not damaged. If you look at that bottom right picture, the middle one shows the wire that I spoke of earlier. Then it's super magnified, and that arrow shows a little pinhole. That pinhole is caused by an ESD shock. That board would pass test. It would go into the factory, into the field, and it would be returned later when it failed, when that trace was damaged. Eventually separated and caused a short. So number 4, ESD control. Number 5, moisture sensitive control. The bag that the ASICs come in, first thing it says on it is it's ESD. Second thing it says is it's moisture sensitive. What's moisture sensitive mean? It's an MSL3, which means it has 168 hours after you open that bag or that part's no good. You can salvage that part by taking the humidity out of it. If you let it sit out for over 168 hours, it will absorb moisture out of the air. You put the heat to it, even if you ramp it up, it will crack, delaminate, and cause field failures later in life. Number 6, the cleaning process. You cannot clean the repair dashboard by dipping it in water. You can't dip it in a tank, you can't spray it off in the sink. There's a whole process of cleaning dashboards. It's a critical process, and if it's not followed, there will be field failures. First, you got to remove the visible dirt. This is an S17 we received. I mean, it has like a cardboard crud on it. And that cardboard crud, the circle blow up, I don't know if you can see it. It's behind me, but if you look at it, you can see dirt on the leads. That dirt causes shorts. So the first thing you gotta do is wash it. And you see the second one shows no dirts on the lead. That was after the initial wash we did on it. So everybody knows now you repair it. Once you get it repaired, everybody knows, well, you gotta clean it. And you clean to get flux off. And everybody knows what flux is. Flux is an acid that prepares the metal to be soldered together. And an inferior wash system, you look at it, it looks like it's clean. The ASICs on these hash boards are bottom terminated components. You can't see underneath the part. So therefore, you don't know if you got it clean. But the more scary thing is ionic contamination. And ionic contamination you cannot see. The little graphic here shows it starts off at the bottom slide of the green graphic as little dots. You can't see them. Eventually they become more, and they cause a short or a failure in the field that you think is your minor, where in reality it was not cleaned properly. The picture on the right shows it. It looks like fungus, and it magically grows towards current. It's amazing. So you have to have it cleaned, and you have to have an extensive cleaning process if you touch a hash board. We actually have 4 main cleaning processes. A manual cleaning tank that takes care of all the metal pieces. Pre-wash process so we can get them clean enough to debug. And then a proprietary multi-phase semi-aqueous cleaning process with a chemistry that we designed for hash boards, and it has included in it an ionic contamination tester. So we statistically measure every cleaning lot to ensure that there's no ionic contamination left on the hash boards. The main machine in this process is 40 feet long. We also have 2 different ultrasonic cleaners, and one of them being a dip tank and one of them being a vapor degreaser. Now, the 7th step is the easiest one. Come by the booth 79 and see us and pick us as your repair facility, and we will assure you that you'll have high quality product coming out of us as a repair guy. If you are a repair person in the crowd, come by and we'll go by all those 7 steps, because if you gradually implement those 7 steps, your business will improve, your throughput will improve, and your quality will improve. That's it. Thank you.